Hello everyone. So let's see the history of Java now. Okay. So in the early 1990s, James Gosling, he was working at Sun Microsystems and he was facing a lot of issues with his current language that was C++. So it had too many issues when he was trying to build large projects with it, and also the limitation that it is very much dependent on your hardware that you're using and also the operating system as we discussed. So uh, it was not like you could compile your code once and run it anywhere. It was not like that, right? So it was having a lot of problems. So that's why James Gosling thought of creating a new language. So if you see the full history of Java, so in 1991, in the early 1990s, James Gosling, Mike, and Patrick, they were three people with Green Team or Team Green, you would say, who initiated this project at Sun Microsystems, and they first called it or coined it as Green Talk by James Gosling, and each of the file extension was also called or represented with a .gt extension, and later he renamed it to Oak. It was developed as part of your Green project, and the reason why he named it as Oak because he had a oak tree just outside his office which he could see from his window. So that's the reason why he actually thought of making it a making the name of the language is oak. Also because oak is a symbol of strength, national tree of US, France, and Germany. So that is also one of the reason. And later, once he wanted it to launch it for the market, uh, then he thought of renaming the name because it was already trademarked by Oak Technologies. And then he thought of two words in mind like Java or Silk. They were the top choices that they had to choose between the name for the high level programming language which they developed. And Java is also an island of Indonesia where the first coffee was produced. And also, Java coffee was consumed in large quantities by this James Gosling. So, hence, Java is just a name and it's not an acronym, and that's where they finalized with this name called Java. And now, in 1995, the first public release of Java happened, and then they came up with Java JDK 1.0. Okay, and uh, the father of Java programming language is James Gosling. He is coined as the father of Java. Okay, and after this, if you see, this is the list of all the versions that uh, Java has released, all the standard editions and the JDKs, so on and so forth. And the most stable, or like the most widely used, or the most popular one was the Java 8 version, which came up with a lot of features which we will be discussing later, like the lambda expressions, functional interfaces, etc. So this was one of the most uh, uh, popular versions of Java, and even now a lot of legacy systems are still being uh, having this old code of Java 8. Now, as of today, if you see, as of today 2026, the latest version of Java that is released is Java 26. Okay, now why learn Java? Is Java still relevant in 2026? The answer is yes, because Java is used everywhere in web apps, Android applications, banking, cloud, enterprise software. Java is everywhere, and 30 years strong. Since its first release in 1995, it's still relevant today. And there are a lot of legacy systems that are already having the old code base of Java, and they are always migrating and keeping updated it with the latest updated JDK, which is JDK 26, which is the latest one. So people are trying to migrate it to the latest versions. And high salaries. Java developers are huge in demand in the industry, and they are very well paid. And the object oriented concepts of Java make it very, very simple to move on to any other programming language. So that is also another point. And billions of devices run on Java, and it has a very rich community with lots of tutorials and solutions to every problems. So that's why learning Java is still relevant, and if you want to get hired, this is one skill that I think you should probably learn in 2026 for sure. Okay, now Whereas Java used, as we discussed, in desktop applications, web applications, mobile applications, gaming, enterprise applications, cloud and servers, and different types of Java applications. Particularly, four types of applications are there, which are basically your standalone applications, which are your desktop applications, and then your web applications used something like IRCTC, Snapdeal. Your standalone applications are like your Adobe Reader. Eclipse IDE itself is built using Java, and for enterprise applications, you have lot of enterprise-related softwares, and then you have lot of mobile applications. These are the four types of Java applications. Now, what is an algorithm? So, the step by step procedure to solve any given problem is called an algorithm. Let's say if you want to make a tea, then what are the step by step process, or what would you do to in order to make a tea? So you would first take some boiling water and then add some tea leaves or the tea bag in it, and then if you want you would add some milk in it, and then you would add some sugar in it, and then you would just serve it and have your tea, right? These are list of five steps that you would follow in order to make tea, right? So this is an algorithm for making a tea. So you can make different types of teas, but this is the blueprint or the algorithm that you would follow to make a tea. Similarly, every computer program is basically an algorithm written using different programming languages. The programming languages can change, but the algorithm still remains the same for a given program. Okay, so we will see that in detail later. What is syntax? Okay, so the correct structure of writing instructions is called as a syntax. Okay, so what that means is basically, let's take an example of English language, which is a human language. If I say watching was I movie, it sounds very incorrect, right? Because the arrangement of the words is set in a way that it is not readable or it is not understood by anyone. Now, if you correct the arrangement so that it sounds, so that it has a proper structure and makes sense, ideally I should have said ki I was watching a movie. So that is a correct syntax. So syntax is a way in which you write the instructions which are only understood by the system. So in programming, if syntax is wrong, the computer cannot understand your code. Computers are fast but not intelligent. They only follow each instructions. Okay, I hope it's clear from this. Now, we have already discussed this, that Java supports write once and run anywhere, but let please be careful and understand this flow very carefully. Okay, so every Java code that you write, it has an extension called .java, and once you compile it using Java C command, which will call your Java compiler, and it will compile your Java code and give you a dot class file as an output. Okay, this dot class file is your bytecode for your corresponding dot Java file. So for this file, you have used your Java compiler and you have generated the bytecode. Now this bytecode can be run on any machine where you have a JVM. So now you give this bytecode to the JVM, and JVM understands this bytecode and converts this bytecode, which is an intermediate code, into machine instructions. And now this machine instruction is something that the system will understand, and it will do the job of what is there inside this file .java. Whatever you have mentioned, it will do and perform the same. So before Java, right, it had to the code had to be compiled separately for each OS and processor, the platform. Basically, for a given platform, you had to compile your code again and generate the file. It was a big compatibility problem. And now with Java, the bytecode runs everywhere via your JVM, right? And now, what is your JVM and bytecode? Um, Intermediate code which is generated by your JVM is your bytecode, like we discussed in the flow, and not fully machine language. It is not fully machine language, it is just an intermediate code. And once your JVM reads this bytecode, it will convert this to a machine level code. Okay, now, JVM converts this, yeah, bytecode to machine code at runtime. And what are the advantages? It is platform independent. It provides security, portability, and easy distribution. Correct. So, what is JVM? So, JVM stands for Java Virtual Machine. So we were using this term JVM all the time, right? It is Java Virtual Machine. It is very important part of Java. So whenever you install your Java JDK, your JVM comes along with it. Okay, and it is responsible for running your Java programs. Different systems have different JVMs, right? So when you install a JDK on Windows, and when you install a JDK on Linux, or when you install a JDK on your Mac, you would get a different JVM. But all these JVMs will understand the bytecode. It doesn't matter which JVM you are using, but all these JVMs will understand any bytecode. So that's the thing. And also it provides memory management, security, error handling, and sandboxing. Okay, now the main key features of Java. So let's see what are the key features. Java is simple. It has no complex features like operator overloading or multiple inheritance, or the concept of pointers is not there in Java, or explicit memory management is not there in Java. All these features are there in C++, but these complex things are not there in Java. You have something called as a garbage collector, which takes care of managing your memory and everything. So it's more simple here. Now, object oriented programming. So Java is an object-oriented programming, so it helps you reuse, write modular code and organized code. We'll see how later on. Okay, and platform independent. You know this already, that you can write once and run anywhere. And secure. Java sandboxing controls memory, file access, and permissions. So JVM is having your control over your memory, and you have the advantage of your garbage collector, right? So that's why it's more secure. And also it is robust because garbage collection or memory handling has become very easy. And also the exception handling feature allows you to handle runtime errors as well, and without letting your application crash, right? So that's why it is very robust. And then architectural neutral. So the size of primitive data types is always fixed regardless of what architecture you are using. Is it a 32-bit architecture or a 62-bit architecture? Doesn't really matter. And now portability, like you know that it is platform independent. Now once you have your dart class file or your bytecode, which is secure, and you can run it on any machine that you want, and JVM will understand. So that is portability. And high performance. So this is very important. You have something called as a JIT compiler, which provides you very high performance. JIT compiler improves your runtime performance by compiling your bytecode or your interpreted code into your native machine code during the execution. So what is multithreading? So multithreading is a feature of Java which enables you to perform several tasks simultaneously. So we will discuss how you can achieve multithreading and run multiple threads and all, uh, what is concurrency and stuff later. Okay, and what is this distributed thing? So RMI is actually remote method invocation. So it's a Java API that allows an object running in one JVM to invoke methods on an object which is residing in a different JVM. So that is RMI. It's a feature. And you have EJBs. EJBs are basically enterprise Java beans. So which is currently known as Jakarta Enterprise Beans. It's a server side component architecture used to build scalable, transactional, and secure enterprise applications in Java. So all these things and programs can run on multiple systems connected via internet. So that's how you can achieve this distributed behavior. Interpreted. So you have something called as a Java interpreter, which converts bytecode to processor enable read only processor readable binary code. um, Basically, this Java interpreter, it's a component of JVM that translates your bytecode into native machine code line by line during the runtime. So I'll just give you an short information about what is a compiler and an interpreter. There's a difference between a compiler and an interpreter. It's very important. So a compiler translates your entire source code into machine code at once before the execution. So this is what a compiler does. Now, while the interpreter, it translates and executes the code line by line during the runtime. So it's not that it will do the compilation of the entire source code. The interpreter will do the execution line by line during the runtime. That is the only difference between an interpreter and a compiler. I hope you understand. And dynamic supports dynamic loading of class at runtime. So this is what Java supports. So that's it for this video. We'll continue in the next video. Thank you.